Hi, with this video I'll show how to read data from the FFV or FFV-Acrobat. So here I have a window for the PIC Kit 2 programmer. I'll select device family, DS-PIC30. Now I'll connect the PIC, which you cannot see, but there are instructions for that somewhere else. I press read. Yeah, if I have good connection, I will get this. Here is the program, which is currently, you can see, same as, but this part is more important. This is EEPROM data. That's where all your ball rotations are stored. But this is, you see, 4D7, that's hexadecimal data. So we need to convert it to understand it better. After some experience, you can even read data like this. What I'll do, I'll make mouse right click button, select all, and then I'll say again right click and copy. So I copy that. Now you open this Excel file that I made, and it says here, after reading EEPROM with PIC2, right click to save. I did that. In this document, right mouse click on cell B4, and it's yellow cell. So I click right, and then I paste, and I have two options, this one or this one. So we go for this one. So it doesn't change configuration of the cells, it just copies the data. So data is copied now. So, and all hexadecimal data is here. Then if we go here, we have all data converted to decimal. So like last ball rotation was 2103 milliseconds, and then it was clicked like 570 milliseconds, and then earlier rotations, and then space for more rotations if there was clocking. Ball direction was selected 1, and diamond hit 3. So in 1/4 of the wheel, that's what the ball made. And then we have here, if we go a little bit more on the right and down, the graph, how that looks. You can click on the graph and then make it larger if you like to see more better. So, but let's go quickly back here. This is now decimal data. You can do with that with what you want. This is first 5 samples saved. Then you have another 5. See, there are only 3 here with data, so other ones are not stored. So altogether there is 8 spins saved. And then here in blue area, it's a difference. Only example, like a little bit what to look for. Here is a difference in between this one and this one. That's this. And then 31 would be difference between this one and this one. And then this last data don't need to compare, because the last data, no, actually that's not the, that's this too. So this doesn't, because that's like when you click quarter or half or 3/4 of rotation. So of course the difference will be different. Okay, press enter, and then you have here the difference. And what you can see, this one is higher, but then a little bit more than 120, then 47, then they go down. Here it's a little bit negative, so this rotation is like little bit badly clocked. And then we can find on the graph appropriate color, so we can look for that. But more importantly, here it's same, but here, because the FF will never use single rotation, so you can see this error here. But when FF use at least 2 rotations, then you can see it goes 28, 34, 28. So it didn't go to like negative difference. So it actually corrected that mistake. So that's alright. If you look the other one, we had 20, 51, 90, because that's like, you can see a ball 1.2 seconds, where like ball deaccelerates the most, and then goes a little bit again down. And then here we have negative, so this one is actually takes longer ball rotations than the previous one, and they all look reasonably okay. But what you can do, for example, you can copy, let's say, any rotations you want to look, but let's say I'll look this 4. I'm not going to copy 0, so it will give me different average. So I'll say Control C, press to copy that. I go down to get some free space, and I'll paste data here. You could see I click here. That's just to copy paste data what is inside the cells. Now I can do click here. I can go to formulas, auto sum. So it marks, it will add all this together. Since it's 4, I will divide by 4 to get an average. And I can go here. So when I click on corner and drag, it repeats everything. So you see this one adding that. And then I can grab and this. And then I can add it here. That's pins. Now I mark everything. And then I go up, and this one should change because I grabbed only 4. This one is an average. So I can grab all, and then I can go insert, line, graph, and I pick this one. And now I can see only dead ball rotations. I make it larger. So you can see average is light blue line, and that's somewhere here. Since it consists of 4 lines, it's probably that's the closest how the ball was deaccelerating. And then you can see the other lines, how they follow it. What you're looking, it's that ball doesn't make, you see this one, but probably wouldn't make any effect because it goes to side where is nothing. But you don't want like big like that, or they like crossing each other too much. See, like this one here, in earlier rotations, of course it's hard when ball is fast. I see the purple one, it's here and then it's here. But then again, this is only when you're looking only single rotation, and it's not so significant, so system will correct it, and it's okay. So it's just showing how you can interpret data inside the FFA, and then you have another 5 sample and another 5 and another 5, and I made on the here also graphs so you can see. So that's second 3 spins. You can also make it larger to see. Oops. Oops, I press Ctrl Z to take it back. I did something badly because I made very small screen, so you can see it better. Yeah, I'm moving something better. Again, Ctrl Z. Here. So I can see like this red one here, it's crossing. Maybe that one can be removed if you want, or something. I don't know what's happening, need more time. I'm just explaining basics. And then let's go back here. Here this graph make a little bit smaller. Here I made just simple converter for one number. If we write, let's say 10 here in hexadecimal, that's A. If we write 100, it's 64. If we write in hexadecimal FFA, that's 4090. So from now on, FFA you can call it 4090. And that's about, now there is a little bit more, but this is only for testing program. I didn't enable it on the normal program. Here also it shows the ball time, last clocked ball time. So it's 1000, because we're clocking 2 rotations together, it's 1857. So rotation was about 0.9 seconds when prediction happened. And then ball 2, so it's one earlier rotation if it was clocked. But this one stayed from previous clocking. So in this prediction it's not used. System knows how many rotations is clocked and how many to use. But it stays in the data, so that's why it's showing it's even greater than this one. And then rotor time was 4 seconds and 52 milliseconds. and this one is result 1. There are 2 results, but result 2 variable get used after in the program, so you cannot see details, but this is meaning that after last click the computer took 455 milliseconds until it produced the prediction signal, so had to delay for 455. Yeah, for some people I can enable this, so that's helping me with some testings, and that's about it. Of course, if you come back here and then you look at data, if your data is much worse, I clock this on a small screen like 23 inch. It's not normal size, and video also making some problems when it's spinning. In real conditions could be better, but depends on your clocking, it could be worse. And it's good that you understand this, so you know how good you are, and then if you you can maybe fix data, work that way, or you can maybe don't use first prediction, but then click another 2 rotation, the system predicts again, then system will have even better data than here, because 4 rotations will be used in calculation, so system can correct more errors. And then if you need any help, you can always ask for help at forum, or if you see at myroulette.com, if you go to shop or some questions, you can see talk to me, where you can see if I'm online, available for chat. When it's saying Forrester I'm online, you can click on that and we can chat. Or if you go to the forum, we can in the profile, not profile, messages, you can also contact me, same thing, where you can see me online, and then you can start begin conversation, and you can write your name or whatever you want here. That's for members and users of the system. Thank you very much for watching.